Welcome back, folks. So we just received in a package, and I believe it's from our sponsors over at PCBWay. So today we're going to get on with our little transistor project and continue on with the astable multivibrator project. You just have to figure out how to get into this package. Boy, they don't normally tape them up like this. They usually take the box and put it in an envelope of some kind. But I guess they got the big roll of brown tape in there. Going to use it. Okay. Usual. A nice pen. A couple of stickers. These pens are actually pretty nice. But let's see, the boards are more interesting. Let's see what they're like. There we go. $5 for $5. Okay, we're going to, I don't know if you saw the previous video, but I kind of separated off. This is the astable multivibrator side, and this side here is the common emitter amplifier, or in this case an inverter. I also changed the pattern on my TO92 just to make them a little bit easier to solder. So I kind of staggered the holes this way and that way, so I can get an iron tip on them a little bit easier. We'll find out exactly how well that works. All right, let me assemble the parts I need to build these. I'm going to build up two of them. One of them I'm going to build up as the LED flasher, and another one I'm going to build up at a much higher frequency, so we can use our little oscilloscope from our beginner's toolkit to have a look at the waveforms. This is the LEDs is going to flash at about 1 hertz, so it's not a great frequency to be looking at on an oscilloscope. So I'm going to make this one run around about 1 kilohertz or so, and that way we can have a look at the waveforms a little bit better. All right, let me get the parts all assembled, and we'll go from there. All right, we've got all our parts assembled. The parts down here are for the LED flasher version, and the parts up here are for the higher speed version. So I'm just going to get started. My iron is all warmed up and ready to go. I've got some solder here, and so I'm just going to get started, and unless something interesting happens, I'm going to speed this up and meet you back at the end. Okay, so we got the two boards are now complete. I'm not going to put these jumpers on right now. And I'm just going to get our beginner's kit power supply here. And this little cable I made up. I should do a video on making up these sorts of little cables. They're great. Now I've got this marked here for 12 volts. That's pretty nominal. They should work over a variety of voltages. So I'll set it up here for 12 volts, but it should work just as well at 9 or 15. Okay, 11.9, that's good enough. Let's plug this in and see if it works. Okay, there we go. That's the astable multi-vibrator. To understand how it works, go and see. I'll put a link to the first video up here where I explain it and show you the circuit diagram. But that's it, doing exactly what it's supposed to do. Now the inverter here is connected to the output here. You can see when I put my finger across this, it's enough to. So when the blue light is off, the inverter will turn on the red light. A better way to do this with a jumper. There we go. So yeah, have a look at that other video, and you can understand how this wonderful little thing works. I was having a discussion the other day with somebody who got himself an Arduino and his laptop, and got the Arduino development environment, and he was so proud that he could make an LED blink using a microcontroller. And I mentioned to him, you don't really need all that. You only use a couple of transistors and a couple of resistors, and you don't need to get your laptop involved and have a development environment and all that to blink an LED. Anyway, basically it's this square wave oscillator, and you'll see when we put the scope onto this one, if you just needed a quick oscillator, a quick little square wave oscillator in one of your circuits, you can certainly just work one of these into it, and away you go. Another alternative, you use a 555 or something like that. But if you didn't have a 555 knocking around, but you had a couple of transistors, the perfect way to get yourself a nice square wave oscillator. The nice thing about this is that you can make this completely symmetrical, totally 50% on, 50% off. If you wanted to make one side a lot shorter, then you just reduce the size of the capacitor on that side. And that's what I did here. This is how I made the higher frequency one. I've just shorted across where the LEDs are with the little jumpers. And I've put in, instead of 10 microfarad capacitors that I have here, I've put in 0.1 microfarad capacitors. So this should run approximately 1,000 times faster than this, assuming that I did everything else correctly. It looks like I assembled this one correctly. So we'll see. We'll get out the little oscilloscope and we'll see how this one works. All right, let's get the power off of this one. And we'll put it onto this one. Smoke test, no smoke. Are we getting oscillation? It seems we are. Okay, I'm having a hard time getting a good connection here. All right, so let's adjust the, there we go. So that waveform of the oscillator right there, you can see it's a fairly nice square wave. It's a little bit uneven. It could be because the capacitors aren't perfectly matched, but we have a duty cycle of about 53% on the high side, which is pretty close to 50. There we go. So, but showing the measurements, you can see that the frequency is 720 hertz, and which is pretty close to where I wanted to get it. I wanted to get around 1 kilohertz. And we've got an output, so there we go, 11.56 volts peak to peak. So if we look at this side, it should be 53% on, 47% off, and the other side would be the other way around. So it'd be the opposite. And the inverter is just going to be exactly, it'll look exactly like this. So if we put the jumper on the inverter, so it should be pretty well exactly what this is like. because it's the inverse of this. There we go. Now we can have a look at the base of the transistors and see what kind of signal we're getting there. So it's sort of a ramp up, and then it holds at the voltage while the capacitor on the other side charges. And it should be exactly the same over here. It should look exactly the same. Move that up a little bit so it's a little bit clearer. So our time base is there, and there. Now we've got more cycles on the screen so you can see better the signal on the base of each of the transistors, and they should both be pretty much the same. And then again on the collector. That's a pretty nice square wave. Now imagine though if you got this up around about 100 kilohertz or so, or getting closer to a megahertz, you'll be running into, you know, the speed of the transistor and things like that. So it might not be such a beautiful square wave. But if you want something anywhere from like 1 cycle in 10 seconds, 1 cycle in 100 seconds, all the way up to maybe 10 kilohertz or so, these are perfect little oscillators for that purpose. Yeah. All right, folks. That's it. Thanks again to PCBWay for making this possible, and thank you guys for coming and watching. And we'll proceed on the next project we do with PCBWay. We'll probably be looking at a linear side of transistors. We'll look at some amplifiers and see what a Class A amplifier is like, and maybe a Class B amplifier. All right then. Thank you very much for joining me, and we'll see you in the next one. Bye-bye.